In this video, we will be talking about multiplying a polynomial by a polynomial. More specifically, a binomial, which is a polynomial with two terms, by a binomial. This is a huge GED test topic. I've seen these type of problems on GED Readies. 2 or 3 questions worth, which is half of the actual GED test. So you can anticipate, 4 to 6 questions relating to polynomials, and even more specifically, multiplying binomials times binomials. So when I have a binomial times a binomial, I'm really just focused on the first term initially, and I want to distribute that term to both terms in the second set of parentheses. So I'm going to look at this 4n here, and I want to multiply that and distribute it through to this 2n and this positive 6. So I have 4n times 2n is 8n squared. And I have 4n times 6, which is a positive 24n. So basically, I want to distribute each term in the first set of parentheses with each term in the second set of parentheses. So next here, I want to deal with this positive 1, and I want to distribute that to both terms in the second set of parentheses. So I want to do a positive 1 times 2n. So 1 times 2n is just 2n. And I have 1 times a positive 6, which is a positive 6. So I have 8n squared plus 24n plus 2n plus 6. So now in our previous lesson, we talked about adding and subtracting polynomials and combining like terms. So now I have 4 terms, and 2 of those terms happen to be like. They have the same variable raised to the same power. So I can combine my positive 24n and my 2n. I have 24 somethings plus 2 more somethings. I now have 26 somethings, or in this case, n's. So I have 8n squared, I'm just going to bring that down, plus 26n, and I'm just going to bring down my 6. Okay. So a binomial times a binomial, in this case, produced a trinomial, right? I have 3 terms now in this simplified set, in this simplified polynomial. So again, just like I shared on the last video, your prompt for a question like this could be to multiply 4n plus 1 and 2n times plus 6. It could be simplify. It could also be find the product of 4n plus 1 and 2n plus 6. And we have to connect that word product to multiply. That's really important. For those of you who remember this topic in high school, it's often taught using the FOIL method, where the F stands for first, so the first terms. The O is the outer. I'll explain this in a minute. The I is the inner, and L stands for last. So I'm just going to rewrite these binomials here. I have 4n plus 1 times 2n plus 6. So my first terms, if I do this right here first, right, I'm really taking 4n times 2n. Those are my first terms within each binomial. And a 4n times 2n gives me 8n squared. Okay, so next, for the outer, they're saying, okay, the outer terms of these 2 binomials would be 4n, change the color, would be this 4n and 6. So 4n times 6 we know is 24n. So my inner terms are the 2 terms that are most inside my set of parentheses. So I have this 1 and 2n. So 1 times 2n is a positive 2n. And then the last terms are the last terms within each set of the binomials. So the 1 and the 6. So 1 times 6 we know is 6. And we get the same thing, right? We get 8n squared plus 26n plus 6. We get the same exact answer. So really you have a couple tools to use, really. The first strategy is using the distributive property twice, which is I recommend doing it that way, because you won't always have a binomial times a binomial. By distribution, it would work if you're multiplying a binomial times a trinomial. And that's where the FOIL method kind of falls apart. It only works for multiplying a binomial times a binomial. But I wanted to mention it in case you do remember that from high school. So really, we talked about this way, distributing what I recommend. And then we talk about FOIL. I do want to mention just one more method, which is the box method. So we know when we're finding the area of something, we're finding the inside, how much space is on the inside, by multiplying the length times the width. So a box method is really similar to the idea, really links the idea of area and multiplication. So my 4n plus 1, I can separate my terms like so. I have just that length, we could say, is 4n plus 1. And then on my left side or right side, I can have 2n plus 6. And notice how I pretty much keep my symbol, my sign in front of the term with that term. So like it's 4n plus 1. I kind of separate those, and a 2n and then a positive 6. And I could look at it like so with this box method. Okay. So in this first box, I have 4n times 2n is 8n squared. I'm taking this term and multiplying them and getting 8n squared. And it doesn't matter which order I go here, which is kind of nice. If I take this 2n times 1, I just get 2n. This bottom left-hand quarter, I have 4n times 6 is 24n. And my last box here in the lower right-hand corner is 6 times 1 is 6. So that really does help lay it out kind of nicely. And I like this way because it also works for multiplying a binomial times a trinomial. So it works. It's really the same as distributive property like we did in the first strategy. It just kind of lays it out nice. Just remember that if you can simplify, you still would, right? So now we need to do something with this. Being I have no signs within my inner terms there in the square, they're all positive. So I have 8n squared plus 26n plus 6. So we just kind of see, we did this 3 different ways, really. And actually, the math behind it is all the same, right? But 3 different strategies to kind of tackle these. And you can choose what one works for you. We got the same answer all 3 different ways. Why don't you guys pause the video and try these next 3, and I'll also work through them with you to check your answer. So multiplying the binomial 8p minus 2 times 6p plus 2, I'm going to distribute this 8p's to both terms. So 8p times 6p is a 48. P times p is p squared. I have 8p times a positive 2 is a positive 16p. Here, just be sure you make this term in the first binomial here that's a negative 2 times 6p is a negative 12p. And a negative 2 times a positive 4 is a negative 4. Combine like terms. I have 48p squared. 16p minus 12p gives me a positive 4p minus 4. Next, I'll do the box method just to change it up a little bit if you prefer this method. So again, it doesn't matter which binomial you placed where. I just always place the one on the left on top. So I have 3m minus 1, and I have 8m plus 7, and I'm multiplying these. So my upper left-hand corner, I have 24m squared. Upper right-hand corner, I have 8m times negative 1 is negative 8m. Lower left-hand corner, I have 7 times 3m is 21m. And my right-hand corner, lower right-hand corner, I have 7 times -1 is a -7. So these are my like terms that I need to combine. So I have 24m squared and a 21 combined with a -8m. You could view that like 21 minus 8 will give us what, 13. 13. Yeah, 13. Excuse me. Positive 13m. And then a -7, we just have to remember to tack that on. All right, last one for this page. 5n times 5n is 25n squared. 5n times -5 is -25n. 6 times 5n is a positive 30n. And a 6 times a -5 is -30. Combining like terms, I have these terms that are like. So I have 25n squared plus 5n minus 30. You may see something like this where we have a binomial squared. So if we really have a good understanding about what squaring a number or a set, anything really, if I square something, I'm multiplying it by itself. So just a little review, if I have 5 squared, that's the same thing as 5 times 5 expanded, right? I'm just multiplying by itself twice. So I'm going to use that same logic here for 7n plus 4. I'm just keeping that as a binomial, and I'm multiplying it by itself. Right, so 7n plus 4 times 7n plus 4. And then now I can use the distributive property or the box method or the FOIL method as long as it's a binomial times a binomial. So 7n times 7n is 49n squared. 7n times a positive 4 is a plus 28n. And really it's the same thing now, right? A 4 times 7n is 28n. And a 4 times a positive 4 is a 16. So these middle terms end up happening twice when you're multiplying the same thing twice, right? So we have 49n squared plus 56n, if I were to combine those two terms, plus 16. Next, I have x minus 10 times x minus 10. So x times x is x squared. X times -10 is -10x. -10 times x is -10x. And a -10 times a -10 is a positive 100. My two middle terms here are like. So I have x squared and then a -10 minus 10x. You could view that like, hey, I'm combining these two. Right? A -10x and a -10x now gives us -20x plus 100. Next, we have a -9k minus 2 times a -9k minus 2. So lots of signs here. This is definitely something you could see on that GED where the numbers aren't always, or the terms aren't always going to be positive, right? They're going to jazz it up and test your integer knowledge too. So here I have a -9k times -9k, so I have a positive 81k squared. I have no idea why that turns red, but a positive 81k squared. So here I have a -9k times a -2 is a positive 18k. -2 times -9k is the same thing, a positive 18k. And a -2 times a -2 is a positive 4. So I have 81k squared plus 36k plus 4. Okay, last one for this video set. So I have a negative x minus 3 times itself. If it's helpful for you, you can put the coefficient in front here of a negative 1. So we have a negative 1x times a negative 1x is a positive 1x squared. I'll put the 1 there for now. A negative 1 times a negative 3 is a positive 3, and then our x. Same here, negative 3x times negative 1x is a positive 3x. Negative 3 times negative 3 is a positive 9. So 1x squared is the same thing as x squared. Just know that it's more proper to remove the 1. But just know that they're equal. I'm happy as long as you know they're equal. But as listed as like multiple choice, you'll rarely see a 1x squared. You'll just see x squared. 3x plus 3x is 6x. And then we just bring down our 9. So I hope these examples really help you understand how to multiply two binomials. Again, it's a very, very likely GED test assessment target. So it's definitely something you really want to understand. The practice in IXL will be hugely helpful.